Hey Internet, welcome to heat transfer tutorial. This is a made up question not found in your textbooks. We've got a light bulb that is 151 watts. It has a filament that is 6 centimeters long. The diameter of the filament is 0.6 millimeters. The diameter of the light bulb is 9 centimeters. We want to find the heat flux on the surface of the filament, the heat flux on the surface of the bulb, and the annual cost for operating 9 hours each day at 9 cents per kilowatt hour. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. We've got this light bulb. The filament is 6 centimeters long, so that is the tungsten wire here. The diameter of the filament is 0.6 millimeters, and the outer light bulb is 9 centimeters in diameter. Step 2, list all the given variables, find the unknowns. So this is just a table of what I just said. No need to go over it again. It's just easier to see. So step 3, find the heat flux formula for part A. So this is heat flux, which is little q dot is equal to big Q dot. So big Q dot is heat transfer rate. In this case, it will be the power, which is 151 watts. We've got the surface area, so power divided by the surface area, and this will be for the filament. Okay, so for the subscript, I wrote surface because heat flux is the heat transfer rate per area, so this is the surface area, and same for the surface area. This is to help students, so just so they don't get confused. Okay, so since we're given power, we need to find the surface area. So step 4, find the surface area formula. We've got pi multiplied by diameter of the filament multiplied by the length. Step 5, we need to convert the millimeters to centimeters to match the units. So you divide by 10, you'll get 0.06 centimeters. So now we just plug and play. So pi multiplied by 0.06 centimeters multiplied by 6 centimeters, so 6 centimeters is the length, and the diameter is 6 millimeters, but we convert it to centimeters. So that's where we got that number from. So you'll get 1.1310 centimeters squared. Step 6, now we find the heat flux for part A. So we just backtrack and plug it in. And let me just copy and paste that so you know what surface area we're talking about. Okay, so 151 watts divided by 1.131 centimeters squared, we will get 133.5102 watts per centimeter squared. So that is the answer, but the standard is watts per meter squared, so we convert that, and that is 1,335,101.68 watts per meter squared. Both answer is correct depending on your professor and lecturer. They may prefer this one, but just to be safe, write both of them in the answer. Okay. Step 7, find the heat flux formula for part B. It's the same one. So the shorthand for surface area is A subscript S. Same for heat flux, it will be little q dot subscript S. I put in the surface, and I should probably put surface of the bulb. So this is just to help students. So if you want to write shorthand, and if you're familiar and you know what you're doing, of course, but I just write it out fully so students don't get confused. Alright, step 8. Find the surface area of the bulb. We assume the bulb to be a sphere, so that is pi multiplied by diameter squared. Step 9, we plug and play. So you'll get 254.47 centimeters squared when you multiply pi by 9 centimeters and then square it. Okay, step 10, plug and play. So in this case, it'll be 151 watts divided by 254.47 centimeters squared. You'll get 0.5934 watts per centimeter squared. And just in case your lecturer or professor or TA who is marking it, it will be 59 or 5,933.90 watts per meter squared. Okay, so that's the answer for part A and B. For part C, we want to find the annual cost formula. So it's the electricity consumption multiplied by cost per kilowatt hour. They give us this one. So electricity consumption is your heat transfer rate, so big Q dot or capital Q dot multiplied by the change in time. So step 12, we now just plug in the numbers. So since it's annual, we multiply it by 365 days. So it's 9 hours per day. So 151 watts multiplied by the change in time, you'll get 496.04 kilowatt hours per year. Step 13, we can now find the annual cost for part C. So now we just backtrack and plug and play. So 496.04 kilowatt hours per year multiplied by 9 cents per kilowatt hour. The kilowatt hour units cancel out, and the annual cost will be $44.64 per year is the annual cost. Disclaimers: the method is correct, however I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Now, before we leave, I highly recommend that you save this video onto your PC, just in case this video gets taken down. While I follow all copyright laws, sometimes things happen. If you're on a Mac, you can use the Mac equivalent of snipping tool. If you never used snipping tool before, follow these instructions. So click on the icon in your taskbar. If it's not there, go to your Windows search, type in snipping tool, open up the program. Click on the video option, then click on new. Left click and drag the rectangle to cover the YouTube screen. Hit the start button in the snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish. Hit the red square and snipping tool to stop recording and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.